So this was an idea developed in 1955 by John Wheeler, and has since been incorporated into loop quantum gravity, the kind of theory that for the longest time stood in seeming opposition to string theory, though for all sorts of reasons I don't think it stands in opposition to string theory, but rather sort of complements string theory. And if we're to make any progress on quantum gravity, I suspect that a unification between string theory, or kind of compromise theory between string theory and loop quantum gravity, would likely be the next step forward. But in any case, yeah, so what is a space-time foam? What is this quantum foam that seems to underlie all of nature, or that people have conjectured underlies all of nature? So this is a foam formed of particles and antiparticles appearing and disappearing and annihilating one another and leading to the emissions of photons in the background. So these photons, these arise as well, as a consequence of these particle antiparticle annihilations, and this gives rise to something called the Casimir effect, or what we might call the cosmological constant. Um, so yeah, this is the vacuum energy of space that we're talking about. This is the tendency that space has to give off radiation. We know that space gives off radiation via general relativity, right? Since Einstein had to incorporate this term into his field equations for gravity to account for the expansion of the universe and Hubble's observations and so on. And this theory of the quantum foam, this really has correlates that go back prior to Einstein, I think, since this foam-like structure for the very smallest regions of space, or the very smallest length scales in space, this foam-like structure, this is an idea that correlates, I think, quite a lot with Maxwell's ether and the mechanical ether of James Clerk Maxwell, and so on. But I'm going to give my own spin on this idea of a foam just now, because I don't quite. I've got my own model of quantum gravity that I've been working on for several years, and this is by all means for you to take or leave. But I don't believe that particle and antiparticle pairs appear in nature and then annihilate one another, because, well, I think it violates the conservation of energy for one thing. What I think really is going on is that electrons are tunneling in the background incredibly rapidly and appear in any given position for an incredibly brief period of time, about a Planck time and so on, or something like that. So it's very easy to get these background electrons confused with virtual particles. Um, and so what's really going on is that background electrons are tunneling around the universe and transporting photons from different regions of the universe to other regions. So in these incredibly small areas of space, what you're getting is electrons popping up there from somewhere else, and then just depositing a photon, a particle of light there. Um, and this is what's really leading to the accelerating expansion of the universe, not particle antiparticle pairs creating one another and annihilating one another. Maybe I don't believe in antimatter. I mean, that's really rather a bold thing to say, and this rejoins upon all of Paul Dirac's work in the 1930s and the whole conjecture and things such as this, and the eventual adoption of the antimatter theory, which I don't think Paul Dirac ever particularly liked. But that's just my recollection of it. I don't think he was ever particularly proud of the idea of antimatter, or wasn't particularly keen on the idea of antimatter. Whether or not it's his idea or not, I'm not entirely certain. I think it would have been his idea, but yeah, I don't think it was something he was quite that pleased with. I don't think it's something that struck him as elegant, and I'm not particularly taken with the idea of antimatter as being that elegant myself. So I have my own ideas about quantum gravity, I have my own ideas about fundamental physics and so on, and yeah, I don't believe in antimatter. And I think that some of the confusion in quantum gravity may have arisen, or probably did arise, really from the introduction of these sorts of ideas early on in physics in like the 1930s and 1940s, and we eventually got this confused paradigm of the 1950s, whereby physicists were really struggling to integrate quantum mechanical ideas with those of general relativity. But yeah, this is a brief video about what a quantum foam is. So yes, thank you for having watched this.